Okay, here we have section 4-6, which is the isosceles triangles. So our main idea is in vocab. Okay, in an isosceles triangle, the angle formed by the congruent sides is called the vertex, and the angles formed by the base and one of the congruent sides is the base angles. So if you're looking at a picture, so say you have a lovely isosceles triangle, so there's the congruent sides. So that angle up there, that's the vertex angle. And those angles there are the base angles. So, which leads us to the isosceles triangle theorems. So 4.9 says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. And then here, the reverse of that is if two angles in the triangle are congruent, then the sides opposite those are congruent. So this is forward and backwards. If you know the sides are congruent, you know the angles are congruent. If you know the angles are congruent, then you know the sides are congruent. Alright, so for example 1, name two congruent angles. So we're going to ignore the fact that they've already marked C and F congruent, but here, so angle ABC and angle ABF are congruent because they are opposite congruent sides. You could also do ACF and AFC. Two congruent sides, well, they've already marked AC and AF, so that would be fine. Or you have this one here, which is BH. So, because BH is actually in two triangles. Or you have, BC is congruent to BF. That's that side and that side. These are opposite congruent angles. So for the angles, we'll actually say AFH, and angle ACH. So that's those there. Alright, last stuff here deals with the corollaries for equilaterals, so they're special cases. So a triangle is equilateral if and only if it's angular, which means that if the triangle has all three sides the same length, it also has all three angles the same amount. And for each angle, an equilateral always measures 60. The reason that is, if the three angles have to be equal, and they all have to add to 180, you have x plus x plus x equals 180. So you'd have like this equation. All three angles are the same, so they're all x's, and they have to add up to 180. So 3x is equal to 180, divided by 3, x must be 60. So if you have an equilateral, the thing to remember is all angles must be 60 degrees. Alright, and our last example here. So it tells you that EFG is like equilateral, so I know that that's congruent to that, which is congruent to all of that down at the bottom. And segment EH bisects angle E, which means that I know that that and that are equal. So it says find the measures of angle 1 and 2. Now, if EFG is equilateral, that means that angle E is 60 degrees, angle G is 60 degrees, and angle F is 60 degrees. And if EH bisects angle E, that means it splits it into two equal parts. So angle 1 is going to equal angle 2, and they're both going to equal 30. These are each half of the 60 degree angle, because bisect means cut in half. For the second one down here where it says find x, so here's a triangle, EFH. There's three angles in it, so that one's 30. We just figured that out. That one's 60, and that one's 15x. And all three angles in a triangle must add to 180. So combine like terms, move the 90 over, divide by 15. So x must be 6. And that's the end of the section.